Hello, good morning. We are continuing on the data types of SQL Server. Yesterday we completed introduction and today we will start on the practicals and examples related to each and every data types. Okay, first data type we have started yesterday is a numeric data types. Out of that, we have five data types under the numeric category. So first is a big data, big int, integer, small int, tiny int, and bit. Okay, so we'll start one by one here. So first data type we are going to study today is a bit data type. So this data type can store 0 or 1, only two values can be stored here. We can use data type for the declaration of variables as well as a column of a table. Okay, I can show you a few examples here. I can declare variable of type bit. I can assign three different values for the this data type. Okay, that can be a null, you can see, or it can be 0 like this. 0 also possible. You can see 0 also can be stored in a variable of type bit. This is syntax actually to create a variable, declare variable name, data type, and then equal to value. Then select statement is a user to display the value over there on a result section. So you can see 0 is mentioned. We'll say one more time here and I will declare it. We'll assign a value 1. That's also possible. Okay. So any value apart from 0, 1 and null that cannot be stored here. You can see all the three values can be stored. You can see null, 0 and 1. If I assign any other value apart from this, it will not store that. You can see if I want to store something like this, like 55 or something, you can see it will not be stored. It will save as a 1 only. Okay. So this is a limitation of bit that it can store only three values, null, 0 and 1. Where that can be used? Mostly this is used for a flag purpose. Like if you want to set some flag for 1 and 0 value, then we use the bit data type here. Just like, for example, we have one column that is used to check whether the active record or inactive records, then we can use their bit data type. Just like if I have different addresses saved on my Amazon account, and what I can do is when I add new address, then what I can do is I can inactive my earlier address. So that case, I have to identify which one is active address. I can use the is active column there. So is active column can be given bit data type because we know that column have only two values, 0 and 1. Okay, 0 means inactive, and 1 means active records. Okay, this is an example where I am declaring the variables of type and bit. I will give you one more example of type of bit for declaration of columns. Okay, over here you can see I'm creating a table as test bit here, and I'm declaring creating column here of type bit. You can see create table name, round bracket open, column, then bit. I'm inserting data, insert into test bit core table. Okay, and then select star from the table. Okay, I can insert value 200 also, but it will not store that. I can show you that. First of all, I will insert 0 value, then I will insert like 1 value, and then I can insert something like the 1, 2, 3 any value, and you will see values stored here are 0, 1 and 1 because the bit data type know only two states. One is the 0 and one of the no, 0 and 1. 1, 2, 3 any other value apart from 0 is a 1 for that. You can see it is showing 1 here. Okay. Next thing we are going to study is the tiny int. Okay. Tiny int is having a size of 1 byte, 1.2. Tiny int in data type, that is a numeric category because we can store number inside this data type. Minimum value can be stored as 0, maximum value can be stored as 255. And how is this calculated? How this range is getting calculated? I already told you how it calculates by using the formula. Because we know 1 byte, size is 1 byte is equal to 8 bit. And if I try different combination of 8 bits, 1 and 0 combinations, there can be a 256 different combination possible. This is one combination. This is another combination. This is one more combination. Just like this, 8 different bits can have 256 different combination of 1 and 0 in 8 places. That's why we can store only 255 number, because we start from 0 to 255. These are the different 256 different combination possible. Okay? That's why a bit tiny data type can store only 0 to 255 values. Okay, if I try to store the higher value, it will give error. Can show you. Tiny can have 0. Okay, and you can see it is possible. Okay, even I can store. Okay, I will try to store like 250, something like this. This also possible. But if I possibly try to add 55, you can see it's still possible to select value. But if I add something like 256 or something, this will be go to out of range value. So it will give error, arithmetic overflow error, because that's a violating limit. Okay. Similarly, I can declare a column in it inside table of type tinyInt, and then I can store data like this. Okay. So any data type we can use mostly to declare variable and create a column inside the table. Any question till this point? One more thing I just wanted to show you is how to check data type length. I'm saying this is 1 byte, 2 byte, something. It can be checked by using this function. Select data length. Data length function is important. Data length function. You can see it's showing you 1 here. 1 means 1 byte. Okay. So this function can be used for any value. You can see whether I'm storing 0, I'm storing 55 or 256, any value I'm storing. It will show you same data over there. Is a data storage type is a 1 byte only. Size is 1 byte. You can see 1. 256 is not possible, so it will not show you. But it's again 1 byte only. Null. It is showing null because no value is stored. I just declare a variable, but I'm not assigning any value. Then you can see it is showing me null. So no storage allocated for this because no value assigned. Only declared variable, not assigning any value. It will show you data length as a null. Okay. So if you are just having a null values over there, it doesn't occupy your space. Okay. Someone can ask you this interesting question. If I have a table that is having 100 records, but all values are null, whether that will require space? Okay. I will show you in that example also in table column. So I will create one table for this. I will create one column out of that. You can see this is my table, one column here, and I am assigning value here null. First value I was assigning null. Okay, and then I will show you data length function can be used to check what is the storage size. Okay, the column is again here, the table name here, and you can see what is the size of a storage for this. You can see null. Okay, means no. If I am storing only null value, then no storage will be allocated for this. If I assign some other values, it will be assigned value. You can see. Even I can check by using sp underscore space used. This is store procedure that is used mostly to check what is the space of data allocated to a particular table. So this is a table name here. I can see it is showing you like data size over there, but it is not. It's allocated to table size, but not storage space taken by this particular column value. Because null is just a emptiness. Okay, null is not a value. Null is not absent. Null is just an absence of value. Any value 1, 2, 3, or 0 even requires some space to store. Okay, but null doesn't require any space to store that value null, because null is just an absence of value. If no value present there, it means there is a null. Okay. So though you can see when you create table, you get this data associated with this table name, but there isn't, when I try to query this particular column, you can see there's a null value. Okay, I can see value also. So value stored is null and space associated with this also null. So no space associated. If I insert some other value over here, like 1, 2 or something, you will see that it will show you particular size. So I'm adding here 1, 2, 3 value. The same query I'm going to fire here. You will see the vendor value is 1, 2, 3 and showing the size is a 1 byte. Okay, so data length is a function that shows you what is the size of data that you have stored inside any variable or or a column. Anywhere it's possible to check the value by using a data length function. Any question about data length function? Any question about a variable? What is a variable? Variable is something that the placeholder that is used in program to store a temporary values. Okay, means in program flow, suppose you want to store some value temporarily during your program execution, you can declare a variable for that. That's a kind of a space holder of particular type. One single value can be stored there, not like a table. Table can store like multiple values that can have multiple records column like this, but it is not possible for a variable. Variable can store hold a value, a single value like this. Like 0 is single value, 2 to 5 is also single value, null is also single value. Okay, so we today discussed examples of tiny int inside of for a declaration of variable, example of tiny int for a column of table. Okay, and next thing over here is a small int. Okay, so this is 1.3. Okay, small int is having size of 2 bytes, so easily you can see if the size is 2 byte, it means it's a 16 bit. Okay, so 16 bit can have how many combinations possible out of 16 bits? If you see the formula here already mentioned, it's showing 65,535 combination are possible. So if we divide this into negative side and positive side, because tiny int doesn't support negative number. Okay, I just forgot to show you that. If I try to add some negative number, it will show you, it will give error. Okay, suppose I want to pass here minus, okay, minus 123, which will show you error because minus 123 is not possible to insert that data. Negative number is not possible to insert it into tiny int type data type. That's why it is showing error. Okay, even if I try to execute or insert the values higher than 255, like 256 or 257 something, it will also give error. The arithmetic shows you the error type is a arithmetic overflow error. Okay, similarly for small int, the total combination are 65,000. I will mention here how many combination possible. There are, okay, 00, 00, then 00, 00. This is a 1 byte. Then for 2 byte again 0000 and 0000 to this one. So from this value to this value, total 65,535 combination possible. So we divide it into two parts, and you can see this is a number value, and this is number line, and on the number line you can see there are positive numbers on right hand side of 0 and negative numbers are left hand side of 0. So if I divide this into two different parts, you can see 32,677 is the highest value that can be stored, and minus 30,768 is the lowest value that can be stored in a small int. I will show you the example in terms of variables as well as a column of table. You can see I'm declaring a variable here and I'm storing the value like 32,767 is the highest value that is possible. You can see their value is getting stored, and storage size by using data link function is showing 2 here. 2 means 2 bytes. Okay, as a storage size in byte. Okay, can show you 2 bytes is storage for small int. Even if I store only 0, then also it will show you same. Okay, तुम्ही म्हणू शकता की झिरो व्हॅल्यू आपण बिट मध्ये पण स्टोअर करू शकतो, टायनी इंट मध्ये स्टोअर करू शकतो, स्मॉल इंट मध्ये स्टोअर करू शकतो. बट सिन्स एवढं तुम्ही प्लेस होल्डर सांगितलं की मला हे एवढं 2 बाईट स्टोरेज पाहिजे, स्मॉल इंट काय सांगतो ऑपरेटिंग सिस्टमला की मला 2 बाईटचं स्टोरेज पाहिजे. तुम्ही त्या झिरो जरी स्टोअर केलं तर तो 2 बाईट घेणारच. ठीक आहे, बिकॉज तुम्ही यूज नाही केली स्पेस टोटली, बट इट इज स्टील इज देअर अलोकेटेड टू द प्लेस होल्डर. झिरो स्टोअर करायला फक्त काय लागतं 1 बीट. ओके, किंवा 1 स्टोअर करत तुम्हाला खूप छोटी साईज लागते, पण तुम्ही डिक्लेअर ऑलरेडी केलं की स्मॉल इंट पाहिजे मला, हे 2 बाईट्स पाहिजेत. ओके, ओएस ने जेवढे अलिकेट करून ठेवलेत. सो यू कॅन सी इवन इफ आर स्टोरिंग 1 or 0, you can see the storage size is 2 byte. Okay, 2 byte here. So I will take one more example of a table wherein I will create a table here of type with a column of type tiny int, small int. You can see create table test table test small int. Okay, and I'm storing this value here. I can store 0, I can store 1 and 267 here. You can see these values are stored. Okay, if I see under data link function, it will show you how much storage is actually used by the particular column. So this data link function I can use. I can see it is showing you these are the values 0, 1 and 30,000, but all the values are taking 2 byte storage because small int is a common data type. Any question till this point? Okay, we'll move ahead for next data type. If I try to assign different value or a higher value, it will give error. I can show you any value apart from this, like 8 or something, it will give error. This is a out of range value. If I try to insert a minus value of this type, it will not show error. Why? Can see this accepted. Why? Because minus side the range is many value already given here. So plus sign is one number less because 0 is counted at the plus sign. So that's why it is a one number less here. If I try to insert higher value than this, it will give error. You can see error here. So what should be your approach whenever you are designing any table? Suppose you are a database designer, or you can say data modeler. You wanted to design database for particular system, secure system, and there is a particular need of storing this kind of values. So you should always try to take a minimum storage. Means suppose you just want to store 0 and 1 value, you should always prefer a bit data type. If you are storing suppose 100 value, 55 value or something like this value, and you know that maximum value is 100 or 150 or something, then you should directly go for a tiny int, because you know tiny int is something a data type that stores value 0 to 255. Because suppose you want to throw suppose human age, any employee age or any person's age, you know, like age of person can be a maximum 100 or around that. So you can use easily tiny int data type. Okay, any value that apart from that higher than that you want to store, you can go for a small int. Any value up that is higher than that, you can go for a integer. Because you can see here, this is a comparison. Like smallest value, if you want to store, you can 0 and 1 can be bit. After the higher one is a tiny int that can have 0 to 255 range. Small int is having this much range. Int is again higher, that is having a 4 byte of a storage, and this is a range for integer. If this is not sufficient, then you can go for higher one, big int. Big int is the highest numeric data type that is a possible currently in a SQL Server. That is again 8 byte storage, and this is a range. Okay. Any question? How we define the range and something? So we'll go for integer now. 1.4. Okay, integer data type having minimum value. Okay, this much, maximum value is this much over here. And how it getting calculated? Because the formula is over there, 2 raised to 32. 32, how come 32? It is a 4 byte. Okay, 4 byte means 32 bits. So formula is 2 raised to 2 to power 32 and minus 1. Okay, but here I have divided into 2 because int data type supports negative number as well as a positive number. So if I go to numeric line, that number line always have two parts here. Right side is a positive number, and left hand side of 0 is a negative number. So if I divide them into two parts, I have to divide over here, divide by 2. So always give you this range. Okay. Any question? Actually, this number 2 raised to 32 is a like this only. Okay. Then divide by 2, actually, and then minus 1. This is a minus 1 is actually outside of bracket. So if I solve this bracket over there, this is a number that comes as the highest number. Okay. So we'll go for first example of type of integer for declaration of variable. You can say declare address j, and that is a sign that is a part of syntax. So any variable if you want to declare, you have to start it with the address sign. Okay. Variable name should start with address sign. This is syntax part. So you cannot like any declare any variable type like datta or something. You have to write always address sign, and then you can name anything over there like address datta, address name, address anything. So address sign is compulsory for a declaration of variable. So I declare a variable here, declare address j int is equal to this value, and I check this stage data length function for checking the size. You can see size showing a 4. 4 means 4 byte storage size allocated to the integer type variable of j. Okay. I can, if I want to store this value, is my mobile number. Can I store this? Even from you can answer. Whether I can store the mobile number into this variable of type integer. This is not possible. Why? Because this is the highest
Size.
number that can be stored. This is the highest number that can be stored. You can see how much digits are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Suppose my mobile number is starting with 1, then definitely it can be stored in integer. Okay. But my mobile number is starting with 9. This is also 10 digit. This is also 10 digit. But this is the highest number. Any number higher than this cannot be stored in integer data type. This is a number. Definitely you can see higher than this number cannot be stored. So you can see it will show you error. Okay. If you want to store this, then you have to go for higher one. That's a big int. Okay. That we are going to see in next example. So interviewer can ask you the question. Okay. Which data type, okay, you will use for mobile number. Your answer should be start. Your answer should be if the mobile number starts with 1, then int is enough. Okay, but if that's not fixed, then go for big int. Okay, okay. So big int can store any number higher than this. Then one more question here. Okay, this is intro question 1. Question 2 will be, suppose you want to store value -1, then which data type you can use. Okay, suppose you want to store only 3 values, like only 0, 1, okay, or -1. The 3 values, possible value. Then which data type you can use for the column of table? Anyone from you can answer this question? Like anything is possible. Yeah, small int.
Small int.
Small
Small
int is
int.
correct answer. Yeah. Like anything is possible. You can use big int, you can use integer, you can use small int. Okay. But you always should try to get a minimum data type that should have minimum storage space. Okay. That will save your space on disk. So small int is a correct answer. Tiny int is not correct answer because tiny int doesn't support my negative numbers. Okay. Then we'll go ahead with the big int. Okay, integer again. You can create table also from this. I can create table of type integer and you can see all these values are possible here. You can see data length is a 4 byte here. I'm using this table. But if I try to insert some other value more than this, it will give error because this number is higher than this. Okay, out of range value. Okay, next one is a big int. Okay, again 8 byte is size, 64 bits. 8 byte means 64 bits, and there can be a these many different combination are possible. But since we know big int supports negative number as well as positive number, so we divide them into two parts. That's why we divide into two parts. Then it will go like it will come into this number. Okay, why this is a one less number here? Because we start from 0, from that is counted from positive side. Okay, so this is the first example here. I'm declaring one variable of type big int, and you can see I can store like this value. Even I can store my mobile number. Okay, I can store mobile number. Can show you. Can see it is checking taking 8 byte storage here to store mobile number. This is maximum number can be possible. I can store this number. I think this is already tried here. Okay, this is already maximum number. If I try to take higher number than this, it will give error. Can see it will show you error. Okay, arithmetic overflow error. This is maximum number currently a computer system can store. Okay, or big int. Big int is the highest data type of integer. So any number apart from this, that will be arithmetic overflow error. Means in the world currently, all computer systems mostly using this much of a number. Okay, if like in future, suppose this number increases, suppose you have designed some banking system 10-year back or 20-year back, and you're using this data type over there, and like after some days, some year, few years, like your bank balance or something, this data like increases, and this number crosses to this number, the system will stop working. Okay, so whenever you are designing any database, any table, you have to think for future, like how many days this is going to work in future also. Okay, okay, then we'll go for few intro questions here. Few more examples, like if you want to store number 55, what can be your smallest data type you can use? Small int. Okay, what is smallest data type you can use for number 11 to 100? Okay, you want to number, you know that number will be between 11 to 100. Okay, what data type you can use? We can use a tiny int because no negative number used here. If you want to store, okay, mobile number starting with a 7, 8 or 9, you should use a big int. Okay, then the different size you can mention. The small int is a having this range, big int, small int, tiny int, all this range you should be able to explain to your interviewer. Okay, next our category of data types is a decimal type data types, decimal numbers. Okay, decimal number have different data types. Decimal number data type category have four data types actually: numeric, decimal, money, small money. Float and real also included there, but they are actually approximate data types, not exact data types. I will show you example also why we call them approximate. But again, all of these are used to store decimal point values like 1.2, 5.2. Okay, like this. I will show you the examples in terms of variable as well as the tables. So first of all, we'll take a decimal. This is a 2.1. Okay, 2.1. This is 2.2, 2.3, 2.4, 2.5, 2.6. Okay. So what is the size? Now data type decimal, what can be a size for that? The size actually varies. What number you are storing, as per that size varies. This is a good thing. Huh? Means suppose you are storing only zero value in big int, still it shows you can see here. Suppose you are storing here only zero value, okay, or one value, only, simply one value you are storing, okay, still it's checking a 8 byte of storage. You can see 8 byte storage is taking only to store one value, single digit value. That can be possible only in one bit also. That is not case with the decimal. You can see if I declare value, declare at that interest rate, I mean, I want to store here in decimal type, and you can see 4 to 2. 4 means total number of digits I want to have a number is a 4. Out of that, 2 digit will be stored for the right side of a decimal place. Means maximum number can be stored for this 4, comma 2 is be equal to 99.99. This is the maximum value can be stored. Okay, because it's saying 4 comma 2. Total number of digit can be 4. Out of that, 2 digit will be reserved for the right side of a decimal place. So remaining 2 will be limited available are left side of a decimal place. Okay, so if I check this data type, use this data type here 4 comma 2, and if try to value store some value 12.45 something, if you check data length here, that's showing you 5 byte data storage. But this is not a constant. If I increase the number, it will show you that higher. Okay, increase the value, then the size will be higher. If I go like this here, suppose I want to take here like 18 and over 12 here, we'll see how much size it's taking. It is showing me. Okay, Okay, 5 byte storage still taking. Okay, basically I will show you what is the precision, what is the scale here. So syntax over here is a declare variable name and decimal and bracket, enter bracket, you have to mention the size of the decimal. Normally int, big int, this is not possible. This is not required. After big int, we do not mention the size. For int, you do not mention any size. But for decimal, you have to mention the size. What is the size you want to store inside this? Okay, what is the data you wanted to store? So I just want to know that interest rate, what can be maximum rate over there? 99.99 is the maximum interest rate can be there. What is minimum interest rate? 0.0, nothing else. So I just go for 4.2 here, 4 comma 2. And this is the data storage size here. If I check in data length function, it is showing 5 bytes. But this is not fixed. Okay. If you see what are the possible storage size for decimal point, these are the different storage size I can show you. 17 byte, up to 17 byte you can have. Okay. If the precision value is 1 to 9, what is the precision value? This is the first value. The first value of the round bracket is the precision value that shows you how many total digit will be there in a number. Like right side of digital decimal place, and left side of decimal place, decimal point. Total number of digits will be precision. And the scale is a yes value, that is a specially number of digits right hand side to the decimal point. Okay. If I mention this value, suppose 12345.9876, okay, something like this. So what is the precision? What is the scale out of this number? Can you tell me? Anyone? If I declare what is just value, suppose, okay, take this value of example and tell me what is the precision and what is the scale for this value. Precision is just nothing but a total number of digits. I will just count
Hmm.
this total number of digits. 1, 2, 3, 4, 5, 6, 7, 8. Then 9, 8, sorry, 9, 10, 9, 10, 11, 12, 13. 13 is a precision. Okay, because 13 digits are there. Okay. If I represent this into precision scale, it should be 13, comma, how many digits are there on right hand side? 8.
Hmm.
Yeah. So this is a perfect representation of this number into precision and scale. Okay. So if I do the precision in between 1 to 9, then total number of digit will be bytes will be 5 bytes. Storage size required. The precision is 10 to 19, then it will go to 9 bytes. Okay. Then is it 20 to 28, 13 bytes, 29 to 38, 17 byte required. Okay. So highest number can be stored here in the 17 byte, that differs to the, this is the highest number you can see. Okay. Why this is something like this? This maximum range, minimum range is mentioned here. And I can show you the examples. Suppose the precision value here 18. What should be the interest rate? I can show you. Okay, it's I can show you 5 bytes. Something I have to mention the higher value. Okay, I will just mention here 18. I don't know it is still 18 or not. Arithmetic overflow. Okay, you can see 9 bytes here. Okay, for this value, it is taking only 5 byte storage. This for this value, it's taking a 9 byte value. Any question? So this is very good. No? You can see, do you declare this 18.2, but if you do not use that value, you just if you use only suppose a very small number, then it's not taking that space. Okay, suppose I declare 18.2 also, but you just specifying here 12.45, then again it's showing you maybe only 5 byte storage. Okay, that's good. That whether you are specified more higher value, number higher precision or scale, then also if it is not required, then it will release the memory and it will occupy only the required space. Okay, same example I will take for the table. You can say I'm creating one interest rate table here that having loan type and interest rate. So personal loan 12.45, home loan 10.1, gold loan 9.5 something. I am storing this value like this. I specify here 4.2 as a column, and you can see the values are used. So if I see a data length function also, it will show you total number of bytes used are only 5 byte storage. Okay, these are the values. When you can write star here and comma to check all values up along with their data size. Same, all the three values are taking 5 byte storage here. Okay, I will try to create one more table here. Test decimal data. Okay, so we'll take this one. Okay, and I will write only one column that are decimal. Suppose I write here. What is maximum possible length here? Is it 20? 38 is possible. Okay, precision value 38 is possible. So I will write 38 here. Okay, comma 2. And I will try to insert some values, random values here. First value I will try to insert is 12.45. Then I will try to insert second value here. 1, 2, 3, 4, 5, 6, 7 something. Then again another value here. Okay. And if you see data length function, that will show you how much space it's taking. For this small value, it is taking 5 bytes. For higher value, it is taking 9 bytes. This value is taking 9 bytes. Okay. Even you can insert more higher, bigger value also to get to see this 13 byte and 17 byte also. One thing I wanted to show you that is about this decimal. Okay. Suppose have try to insert bigger value for this. Show you that one. Suppose I mention here 4.2, but suppose I write to by mistake I inserted so many decimal point values. So what will happen after that? Whether it will save or not? You can see it will not save. It will direct round up that values into only two decimal places only, and ignore all the different remaining decimal places. Okay, is that clear to all? It will not give error basically. Interviewer will ask you the question whether it will give error or not. Okay, if I give something a value like this, like 99.123 something, again you can see this will not give error. It will just cut down all the remaining values and it will keep only 12 because only two decimal places are reserved. So any value apart from that, it will be removed. Okay. If I write like 0 point something, then it will be saved or not. Again, not possible because it is showing only two. Out of four, only two decimal places are reserved. So out of all remaining three and four values are numbers are cut down and only 12 will be saved. Okay. Even I write like this 1, 2, 3. If I don't use this one, okay, only decimal place I want to store, then also not possible. It will show you error because maximum number can be a okay 99.99. Any number higher than that not possible. Okay. We will move ahead with the numeric data type. So numeric is exactly same as a decimal. Then I don't specify anything about that. I will just say minimum value exact same as decimal, max value exact same as decimal, storage exact same as decimal. Yeah, I will show you syntax also exact same as decimal. No differences. Just a Whenever you are referring anything about this decimal, you have to just specify here numeric. I can show you. Then why there is need of having decimal and numeric if they're having same thing, everything is same, maximum, minimum, range, storage, everything is same. So why we need this different value, different data type? But it is only to obey the ANSI standards. Okay, numeric is something that is ANSI standard, and decimal is specific to SQL Server. Okay, can show you these values. Same thing. I can use data link function also for this. You'll see storage size also same. Interest rate I'm storing here. You will see same storage size of 5 bytes. Okay, you can see 5 byte here. So everything same for numeric as a decimal. There is no difference at all. If interviewer asks you a question that why, what is the difference between a numeric and decimal, you have to say there is a no difference in syntax, no difference in any attributes, properties. Everything is same. Only difference is one of them is a ANSI standard, one of them is a static specific to SQL Server. Okay. If I write any query with the ANSI standard only, then what will happen? That query will exactly will be can be executed on any other database. Like I can execute on Oracle, I can execute same query on MySQL because all databases when you develop they follow the ANSI standards. Okay. But if I use some data type, some syntax that is specific to SQL Server and not specific to ANSI standard, then that cannot be that query cannot be executed on any other database. That can be only for a SQL Server, Microsoft SQL Server. So that query cannot be portable query. Okay, next one is a money type. Money is something about again name is itself saying money means it is just showing for only money purpose. Okay, monetary purpose. If you want to store some account balance something, then you can use money type. And what is the difference between that money and decimal then? Decimal can also be used. Then money is specific because money now is fixed. Okay, 4 byte stored here right hand side and the remaining bytes over the left hand side. Okay, storage size is a okay, 8 byte storage. This fixed. Okay, if I see, I declare one variable here, interest rate in money. You can see 12.45. I will check data length function. 8 byte storage is required. If I try to add some more decimal places here, it will not save. It will ignore everything apart from 4. Okay, 4 only digit will be stored. 4, 5, 1. Apart from that, after that, whatever remaining decimal numbers I have added, all those will be removed. You can see here. Because only 4 digits are allowed after decimal place. Okay, so minimum value with this. Okay, minus value. And this is the max value, plus side. Okay, another type, if you don't want to waste your space, like this 8 storage is a huge space. You want to save some space, you can use a small money. Small money is also good. If you want to store some amount that is a not big amount, then you can go for a small money. Okay, small money has a storage size of 4 byte and there is a range also small. You can see this much range possible. 2,14,748. This is the highest number that can be stored. Okay, this is the highest number that can be stored in a mini. Over here you can see. If I save this, this will you just ignore this one. It is possible here. Okay, if I write anything value higher than this, it will show you error. because this is a arithmetic or player, we call it out of range value. Okay, and this is a possible for minus value. Many values possible this. Any value apart from this is a give error. This is a is successfully completed. So that's how what a small int. If I see the data storage space, can check by data link function. Okay, this is a this j, and you'll see the storage size also. It's taking only. Okay, just leave it for this. You can see it's showing a 4 byte storage. Okay. Any question till this point? Okay. You can create the table also. Like I'm creating table where I'm using integer, money, small money in a same table and inserting some values, and you'll see these values here. That is possible. Okay. Any question? Okay, next that type over here is a float and real. Okay. So we'll go through this also. Float and real is also kind of a decimal place that lives 2.5 and 2.6. Okay. Then again, these are the minimum value, max value. Okay. So what this means? Okay, this means you know how to resolve this exponent. This is a kind of a exponent, nothing but power function. Okay. If you want to resolve this, it can be over there equal to 3 point here equal to 3.4. Okay, multiplied by 10 to power 38. Okay, this is the meaning of this particular number. Okay. Any question up to this point? can give some example here. This means 10 raised to 3 and something like this. Okay. These are the few examples of exponential values. Okay, we'll take few examples for the variable as well as a table. So I'm declaring one variable here of type float, then real and real. Okay. If I see, I will also use a dataLine function to show you how much space it's taking. So if you see space wise, it takes 4 byte when precision less than 25, 8 byte if precision is a greater than 25. Okay, it up to 53%. So over here you can see I have not mentioned the float, any precision not mentioned here. So by default it takes higher one. So you can see if I see here, I'm just storing small number, still it's showing you 8 byte storage. Okay, 8 byte storage here. If I specify particular number with particular precision, like if I know that this number will be smaller one, so if I can write like this, like 10 or 12 something, showing me only 4 bytes. Okay, if I take higher one, it will show you, like if I take 53 or something, that can be a 8 byte. Okay, again this is the real one. Real is also same kind of storage, same kind of data type where we can add, but this is smaller one. Real cannot be higher than 4 byte. Real doesn't take any precision value like this here. So any value if you want to store, it will take. You can see this will be always a 4 byte. Okay, see I'm just checking this number over here, but because since it's having limitation of size, it will not take all the other values. It will cut down to the remaining. Okay, that's why it is called as a approximate data type. It will not store exact value, it will store some approximate value. Okay, that's why real and floats are avoided. Mostly we should use real, decimal and numeric. Any question till this point? Interpretation can be like this over here. Okay, y float is a approximate data type. Okay, answer will be like this. Okay, in SQL Server. Okay, float data type is approximate numeric data type that stores of floating point numbers. Float values are approximate in which that not all values can be represented exactly. Loss of precision comes to the cost to the faster processing times. Okay, means why loss of precision is very matters whenever you are accounting or you are doing some bank balance uh, auditing sometime. If you use float or real, it comes whenever you adding some subtraction and then uh, means addition subtraction you are doing with a lot of decimal values, that loss of decimal value will come to the very bigger, very higher when you the values are like 100 values are calculating, 200 values you are calculating with, and little bit difference also it goes to the higher value you calculate that number. Okay, so I think we can stop for today. We'll continue tomorrow on remaining things. Thank you. Bye bye.